Hello everyone. Today we're going to talk about single replacement reactions and the activity series list. Single replacement reactions are reactions that follow this pattern. We have a single element that basically breaks up a couple, usually ionic. And so A is going to try to join with BC, which is an ionic compound made up of a basically positive cation and anion. And when the product comes together, A, as I said, is going to replace B to combine with C. Therefore, B is going to end up alone. Now, there are a couple rules that, just one rule that applies. A can only replace B if A is higher on the activity series list. So this is the activity series list, and it's essentially a popularity list. You'll see that the elements that are listed at the top are going to be more reactive than the elements that are listed at the bottom. They are very unreactive. And so if A is more reactive than B, then the reaction will proceed. But if A is not more reactive than B, then there will be no reaction. All right, understanding this, let's do a couple problems. So the first one that we have is Ag plus KNO3, potassium nitrate. So again, and an element that's very important is you have to understand the two parts of your ionic compound. So we can see right here that potassium is the metal ion, and the anion is going to be a nitrate. Since Ag is also a metal, it would want to replace K. Ag will want to replace K. So let's look at the list. Is Ag higher than K? Well, let's look at them on the list. And I'm going to highlight them in yellow. So Ag is right there. That's silver. I don't know if you can see that. Maybe what I'll do is I'll circle them, highlight them in pink right there. Or I will, let's say, we'll just circle them in red so we can see Ag is right here as opposed to K, which is up there. Now, as you can see that because Ag is lower than K, this cannot happen. There will be no reaction. Second example. Let's see that we have zinc that wants to combine with AgNO3. We can try to predict whether the reaction happen by comparing again Ag and Zn, right? Because they're both, a cation will seek to replace a cation, or a metal, and a non-metal will want to replace a non-metal. So because Ag are both metals, they're going to try to compare to each other. Okay, so we look at Ag and NO3. Let's look at them on the list. Okay, so as you can see, Ag is at the bottom, but Zn is at the top. So in this case, yes, the reaction will proceed. And now Zn will combine with, remember Zn is 2 plus, NO3 is 1 minus. So when they combine, we're going to just simply crisscross those charges, right? So now we have Zn1, which is invisible because we have a charge of 1. And then NO3, right? That charge right there, that 2, is going to now come down to where NO3 is. So now we have ZnNO3. I just want to show you how I get this in case you forgot. So let me write it over here, ZnNO3, 2. And then, of course, Ag is going to be left by itself. So now all we have to do is balance our equation. We have, and again, I'll do it quickly for those of you who don't remember how to balance. So we have Zn, Ag, NO3. We have one Zn on the left and one Zn on the left, on the right. One Gan on the left, one Ag on the left, one Ag on the right. And then we have one NO3 on the left and 2 on the right. So as we can see, this right here does not follow the law of conservation. We're going to have to put a 2 over here in order to make this 2. So by putting a 2 there, not only do we have 2 NO3, but we've also created 2 AGs, right? So we need to put a 2 over here for this to balance. I hope this makes sense. Awesome. So now let's go on with our third reaction. And let's do this one. Let's do Cl2 plus Ki. Okay? And in this case, I like this reaction because, again, your first thing would be, oh, you take the first one, you want to try to replace it by K, right? That's what it looks like at first, but this is actually not correct. What happens here is that you have to identify whether your elements are metals or non-metals, or cation and not, or cation. As you can see right here, this is actually a non-metal or a negative anion. It's a non-metal, right? And in the second part, I is actually also the non-metal, while K happens to be the metal. What does that mean? Well, that means that K will seek to replace I, or Cl will seek to replace I and not K. Super important. So, again, if we look at the activity series, and I'm going to erase there, let's find potassium. We see that potassium is up there. And chlorine happens to be chlorine because it's a halogen, happens to be actually higher on the list. It's not showed over here, but it happens to be higher on the list. And so because it's higher on the list, we can proceed with our reaction. So the given product will then be K and Cl. So remember, we're trying to remember the respective charges. We see it's a 1-to-1. Therefore, this will become just KCl, right? So let me write that down over here, just KCl. And then what will be left over is I. Now remember, I is a group 7 element, becomes a gas, therefore it's diatomic. It becomes I2. Now, and now we are done. Now I'm going to do one more. And in this case, I'm going to give you another reaction. And I want you guys to see if you can predict it. So we have copper that we're going to join to iron sulfate. And I want you to tell me, first of all, which element is going to seek to replace or break up the pair over here, okay? So you see you're going to try to replace Fe or SO4. Think about that. Okay, very good. We have to see that Fe and Cu are both of the same kind, right? They're both metals. They're both uh, they're both cations. And so Cu is going to seek to supplant Fe. Looking at the chart up here, we see that Cu is actually found right here. That's copper. And let's see if it can replace iron. Iron happens to be higher. So no, the reaction cannot happen. So I want to tell you something. There's a mistake in one of the equations. Can you find it? So please pause the video and see if you can find where the error is. Great, you found it. That's right. I did not balance this equation. So you can see here we have two Cl's. So that means I need to put a 2 here so that now we have two Cl on the left and two Cl's on the right. But by doing that, I've now created 2 potassium. Therefore, I need to put a 2 here so that now we have 2 potassiums on the right. And that also create 2 I's on the left, and we already have 2 I's on the right. Good job. I'll see you in the next one.